Welcome to a captivating journey through the enigmatic realm of the majestic planet, Saturn. In this awe-inspiring video, we will explore the mesmerizing phenomenon of Saturn's youthful rings gradually vanishing, delving into the scientific discoveries, theories, and mysteries surrounding this cosmic spectacle. Get ready to embark on an extraordinary voyage to uncover the secrets hidden within the fading rings of Saturn, leaving us mesmerized by the ephemeral beauty of the universe. Saturn's iconic rings, a breathtaking sight in our night sky, may be destined to vanish, leaving future generations unable to witness their celestial beauty. Recent research analyzing data collected by NASA's Cassini mission, which studied the gas giant planet from 2004 to 2017, has shed new light on the age and potential disappearance of these majestic rings. The findings, presented in 3 studies published in May, offer intriguing insights into the timeline of Saturn's rings. Dating back to the formation of our solar system approximately 4.6 billion years ago, Saturn's rings have long fascinated scientists who have debated their age and origins. Some astronomers argue that the bright and icy rings must be younger than expected because they haven't experienced significant erosion and darkening due to interactions with meteoroids over billions of years. The analysis of Cassini's data has brought forth a compelling finding that aligns with this theory of the rings appearing long after Saturn's initial formation. A study published in the journal Icarus on May 15 supports the notion that the rings are relatively young by astronomical standards, estimated to be only a few 100 million years old. 2 additional studies, published on May 12th in Science Advances and May 15th in Icarus, respectively, reached similar conclusions. Richard Durrison, a professor emeritus of astronomy at Indiana University, Bloomington, and the lead author of both Icarus studies, expressed the significance of these findings. He stated, "Our inescapable conclusion is that Saturn's rings must be relatively young by astronomical standards, just a few 100 million years old. If you look at Saturn's satellite system, there are other hints that something dramatic happened there in the last few 100 million years. If Saturn's rings are not as old as the planet, that means something happened in order to form their incredible structure, and that is very exciting to study." To put this time frame into perspective, it is believed that Saturn's rings were still in the process of formation when dinosaurs roamed the Earth. The implications of this revelation are profound, as it suggests that a significant event occurred within the past few 100 million years that shaped the extraordinary structure of Saturn's rings. As scientists continue to unravel the mysteries of our vast universe, the study of Saturn's rings provides a captivating opportunity to explore the dynamics and evolution of celestial bodies. The impending disappearance of these iconic rings invites further investigation into the forces and mechanisms that have shaped our cosmic neighborhood. While we may be fortunate to witness the magnificence of Saturn's rings today, the knowledge that they are ephemeral reminds us of the transient nature of celestial phenomena. As we strive to unlock the secrets of the universe, let us cherish and appreciate the wonders that grace our night sky, for they may one day fade away, leaving only their enchanting legacy in the annals of astronomical history. One of the primary revelations from the Cassini mission's observations during its grand finale, a series of 22 daring orbits between Saturn and its rings, relates to the presence of meteoroids within the rings. These tiny rocky fragments, similar to sand grains, collide with the ring particles, generating a cloud of floating debris as the ring material orbits the planet. By studying the interactions between these meteoroids and the rings, scientists were able to obtain valuable data regarding the pollution levels of the rings, the mass of the rings themselves, and the rate at which ring material precipitates onto Saturn. Analyzing the data collected during the grand finale, researchers consistently arrived at the same conclusion, a finding that supports the theory of the rings' relative youth. They discovered that the amount of cosmic dust, which regularly traverses our solar system, accumulated on the icy rings was remarkably low. Over the course of 13 years, Cassini's cosmic dust analyzer managed to capture 163 dust grains originating from beyond the Saturn system as they swirled around the gas giant. The surprising cleanliness of the rings suggests that they have not been in existence long enough to accumulate a significant amount of cosmic dust. Simultaneously, the infiltration of meteoroids into the rings has been found to have a significant impact. These meteoroids, as they enter the rings, propel ring material from the innermost regions towards Saturn at a rapid pace, Cassini's observations revealed that the rings are losing several tons of mass per second, indicating that their lifespan from an astronomical perspective is limited. Based on these observations, scientists estimate that the rings will endure for only a few 100 million years at most, reinforcing the notion that they are relatively young in comparison to the age of the solar system. The notion of Saturn's rings vanishing within the next few 100 million years aligns with previous research, which had postulated their disappearance within 100 million years. This revelation adds a sense of urgency to the study of Saturn's rings, emphasizing the need to further explore and understand the dynamics that govern their existence. The insights gained from the Cassini mission's meticulous observations and measurements provide scientists with a rare opportunity to delve deeper into the mysteries of planetary rings and their evolution. The revelation of the youthful age of Saturn's rings not only prompts further investigation into the specific events that shaped their structure, but also raises intriguing questions about the broader implications for our understanding of planetary formation and dynamics. Paul Estrada, a research scientist at NASA's Ames Research Center and a co-author of the 3 studies, emphasized the transient nature of massive rings like Saturn's, stating, "We have shown that massive rings like Saturn's do not last long." This revelation raises intriguing questions about the rings surrounding other gas giants in our solar system, suggesting that they might be remnants of once massive rings akin to Saturn's. Estrada postulates that in the not-too-distant future, astronomically speaking, after Saturn's rings are ground down, they may resemble the sparse rings observed around Uranus. The dark rings encircling Neptune and Uranus, which exhibit a different appearance compared to Saturn's rings, are thought to have undergone similar transformations. The researchers proposed that these rings were once larger and brighter, resembling Saturn's current rings. However, the exact processes and events that created Saturn's rings remain elusive. While scientists have yet to ascertain a definitive answer, one theory suggests that gravitational instability might have disrupted some of the icy moons orbiting Saturn, leading to the formation of rings composed of the resulting material. Jeff Cousy, a principal investigator at NASA Ames and co-author of the Saturn research paper published in Science Advances, highlights the significance of the Cassini mission's measurements. He asserts that the trifecta of data collected by Cassini makes it challenging to avoid the conclusion that Saturn's main rings are a relatively recent feature in our solar system. This finding has sparked interest in future missions focused on studying Saturn's moons, as they hold the potential to unravel the events that gave rise to the rings and potentially uncover new discoveries. Understanding the mechanisms behind the formation of Saturn's rings could also shed light on the enigmatic moon Enceladus. Enceladus has garnered attention for its remarkable geysers that erupt from deep ocean plumes, spewing water, ice, and even organic materials into space. Richard Durrison, a researcher involved in the studies, speculates that unraveling the mysteries of Saturn's rings might provide insights into the intriguing phenomena occurring on Enceladus. Exploring the events that shaped Saturn's rings could potentially reveal the building blocks of life itself, offering a tantalizing prospect for future scientific endeavors. The revelations from NASA's Cassini mission have brought us closer to understanding the age and potential disappearance of these celestial wonders. As we delve into the scientific discoveries and theories surrounding Saturn's fading rings, we are reminded of the ephemeral beauty of the universe. Like and subscribe now and embark on this extraordinary voyage of discovery.